Hello to everyone. Today we are going to solve the NCERT chapter 10th class surface area and volume, and chapter number is 13. And today we are going to solve the questions of exercise first, that is 13.1. So we are going to try to first understand the question, what is the question, and according to the question what is asked, we are going to solve it by step. So let us start. Okay, so the first question is two cubes, each of volume 64 centimeter, cube are joined end to end, and we have to find the surface or area of the resulting cuboid. So we have two cubes, and each is having 64 centimeter cube. So that is the volume of this one cube, and they are joined end to end. So they are joined end to end means we have joined the middle part of this, and we have to find the area of the resulting cuboid. Now if this one is cuboid, here the length, right, and breadth and height is different. So first given is the volume and we resultant with the cuboid. So to find the surface area of cuboid, we should know the formulas of each. So one is cube. So let us write the volume of a cube. So what is the volume of a cube? That is a cube. And given is 64 centimeter cube. So if we are going to take cube root on both sides, taking cube root on both sides, so we have a is equals to, so 64 can be written as 4 into 4 into 4, it's cube root, and that is centimeter. It means 4 cube 1 by 3 centimeter. So side of cube is 4 centimeter, right? And now we have to find the surface area of this cuboid. So this one is your length, this one is your length L, this one is your breadth, right? So this one is your breadth, and this one is the height. So we can write it as this one is the length, height, and the breadth. Now cube is joined, so if this one is here 4 centimeter, this one is also 4 centimeter, so 4 plus 4, it becomes your 8 centimeter. And because this one is cube, so height will be 4 and the breadth will be also, we can say width is also 4 centimeter. Alright, so we can write first the formula of surface area of cuboid. And surface area of cuboid is 2 into length into width plus breadth into height, or height into breadth. So as we know, length is, we have find it that is 4. This one is also 4. So 8 into breadth is 4, and again height is 4, then 4 into 8. So we can solve this one. 8 into 4, 32, plus 16 plus 32, and just add these values. So if we are going to add them, so what we are having, so let us see. That is 2 into 80, and we get 160 centimeter square. So that's it. So if we have two cubes with the volume 64 centimeter cube, and we join them end to end, so the surface area of this resulting cuboid is 160 centimeter square. So that's it. So let us discuss now the second question. So the second question is, a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter, and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. So given vessel in the form of hollow hemisphere, and that is mounted by a hollow cylinder. So let us discuss first the diagram, okay, and then we proceed for the solution of this particular question. So you can see here, this one is your cylinder and this one is your hemisphere, and the diameter of this hemisphere is 14 centimeter. So it is already specified. So diameter of this hemisphere is 14 centimeter, and the total height, so height is given 13 centimeter. So we have to find the inner surface area of the vessel, right? So a surface area, so combined surface area of this vessel, because this vessel is consists of two shapes. One is your cylinder and other is your hemisphere. So first of all, we have to understand the hemisphere surface area. So here we are taking the curved surface area, okay, not total. And here also the surface area of cylinder, that is again a curved surface area. Okay, so let us write first the formula and what is given to us. Let us write. So here, what is given? So given is a diameter of the hemisphere, and that is 14 centimeter. So therefore, radius of this hemisphere will be, as we know, radius is diameter's half. So it will be 14 by 2, that is 7 centimeter. Now total height, total height of the vessel is 13 centimeter. So if we want to find the height of cylinder, so it will be height of vessel minus height of hemisphere. So height of vessel is given 13 centimeter and minus height of hemisphere, that is the radius, or we can say radius of hemisphere. So 13 minus 7, that is 6 centimeter. Now the curved surface area of vessel, that will be curved surface area of cylinder plus curved surface area of hemisphere. So curved surface area of cylinder is 2 pi RH and curved surface area of hemisphere is 2 pi r square. Now we can take common here 2 pi. Here r will be same because it is having a common radius for the cylinder and the hemisphere. So we can take also the radius. So r can be taken as out, and here h, that is the height of the cylinder plus radius of the hemisphere. So just substitute these values. So we can put here 2 into 22 by 7. Here radius is here 7, and inside it will be 7 plus 6. So here we can cancel out this 7. So 44 into 13. So if we are going to multiply this 44 into 13, so we are having 572 centimeter. That's it. So we have find the surface area of this given vessel. That is the combination of cylinder as well as the hemisphere. So we have a diameter and the height of the total vessel. So by using these things, we just apply as we know the formula, because we are using here the curved surface area. So that's why we use the formula of curved surface area of cylinder as well as for the hemisphere. Now let us discuss the next question. The third one is, the question is, a toy is in the form of a cone with a radius 3.5 centimeter mounted on a hemisphere of a same radius. The total height of the toy is 15.5 centimeter. Find the total surface area of the toy. So toy is in the form of, again, two shapes are taken. One is here cone and other is hemisphere, and hemisphere is mounted on cone. So let us draw first the diagram, and then we are going to solve the question accordingly. So here you can see, here we are having, this one is your hemisphere, this one is cone, and again given is radius, and it is specified we are having a same radius. So radius is here 3.5 centimeter, and the again total height is given 15.5. So again we have to find the total surface area of this toy. So again it is very much simple. So first given is radius, and we have to find it, because here total surface will be combination of curved surface area of this cone as well as the curved surface area of the hemisphere. So radius is same for both the shapes, that is 3.5 centimeter, and total height is given 15.5 centimeter. So we can find the height of this cone by subtracting the radius of this hemisphere. So we have h here, and then what is the curved surface area of this cone? So curved surface area is 2 pi rl. So we have to find the value of L. So L is your latent height. So what is the latent height? Latent height is L is equals to R square plus H square under root. So we can find the value of L, and we know the curved surface area of cone, right? So we are just going to find first L, and then we are just substituting the value of L in this curved surface area of cone, as well as we are going to find the curved surface area of this hemisphere, and just join these two curved surface area, so we will get the total surface area of the given toy. So let us start. So let us write first what is given to us. So radius is given, radius of the given toy, because cone and hemisphere both are having the same radius, so I'm just going to write the radius of the toy, and we can denote it by R, and that is 3.5 centimeter. And total height is given, total height of the given toy is 15.5 centimeter. So we can find the height of cone, and it will be total height. Total height can be represented by capital H. So total height minus radius of hemisphere. So height of cone can be represented by small h. So we can write 15.5 minus 3.5. So we have 12 centimeter. Now we can find the latent height, or we can say the slant height, and it will be denoted by L. So that is R square plus H square under root, or we can write 1 by 2. Both are same thing. So R is here 3.5 square plus 12 square, and it's under root. So what will be the value? Let us find out. So here 3.5 square is 12.25, 12 square is 144, and when we add these values we have 156.25 and take the under root, so 12.5 centimeter. So that is the slant height, that is L. Now we are going to find the total area, total surface area. So total surface area is curved surface area of cone plus curved surface area of hemisphere. So we have all these values. So curved surface area of cone is pi r s, and that is 2 pi r square. So pi is common, r is common because radius is same. So inside we can write L plus R. Okay, so here pi is 22 by 7, R is 3.5, L is 12.5, and R is 3.5 again. So let us solve this value. So we have 22 by 7 into 3.5 into, so now you can see here we can add 12.5 plus 3.5, we are getting 16. So we just cancel out these decimal, and 7 into 5. By solving this we are getting a total surface area, that is 176 centimeter square. So that is the surface area of this given toy, whose radius is 3.5 centimeter and height is 15.5 centimeter. Alright, so let us take now the next question very quickly and solve it. So the question is, a cubical block of side 7 centimeter is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? And then we have to find the surface area of the given solid. So we have again two shapes. One is your cubical and the other one is your hemisphere. So hemisphere is mounted on that, and we have to find its greatest diameter, right? So let us see first the diagram of this one. So you can see here, this one is a cubical block, right? So cubical, it means all the sides are equal, that is 7 centimeter, and this one is surmounted by a hemisphere, you can see here. So we have to take the greatest diameter of this hemisphere. So how much it can be? So simple, if it is can be have a diameter if it is totally equal the cube. Okay, so here you can see, if we are drawing a hemisphere from one end to the other end, and that will be a 7 centimeter. So diameter that has a greatest diameter, that is a 7 centimeter. And now we have to find the surface area of this solid. So here one thing you have to be remember that, so this hemisphere is just taken up on this cube. So whatever this area that is pi r square that is having, that we have to subtract, because it will be not taken in this total surface area, that it is subtracted from this given cube. Okay, so first we are going to write what is the total surface area of this solid. Okay, and it will be more clear to you when we are just write down this total surface area of this solid. So let us write. So here you can see the surface area of the solid is surface area of cubical block plus curved surface area of hemisphere and minus pi r square. So minus pi r square is here. Why it is? Because of this area. Because it is occupied by hemisphere, so it is not specified, right? So it can be cancelled out, because we can't add a term, because this one is not included in a curved surface area. Okay, so that's why we are having here 6a square plus, that is curved surface area of hemisphere, minus the pi r square. Now, as we already have discussed, the greatest diameter of this hemisphere is 7 centimeter. So we can write it here. Diameter of hemisphere is 7 centimeter, and therefore radius of hemisphere is 7 by 2 centimeter. So we are just going to substitute these values, as we know the side of cubical block is 7 centimeter. So this one can be specified as, represent as D, this one is your R, and this one is your A. So we are going to substitute all this. Let us take this one is equation number 1. So surface area of solid is 6 into 7 square plus 2, and we can see here it is 2 pi r square minus pi r square. So we can write directly here pi r square. So we can write here pi r square. and that is 49 into 6 plus 22 by 7, and R is here 7 by 2 into 7 by 2. So we can cancel this out, and 49 into 6 is 294, and plus it can be written as here 22 into 7 by 4. 22 into 7, 154 by 4, and that is 38.5. 294 plus 38.5. So if we add this value, so we have here 332.5 centimeter square. So this one is the total surface area of this given solid, and that is surmounted by a hemisphere. And first we find its greatest diameter. So here we have find the greatest diameter, as it is occupied by this surface already. So we have to subtract this one. So our surface area of this solid becomes surface area of cubical block plus curved surface area of hemisphere and minus 5r square. So we have 332.5 centimeter square. Now let us take the next question and try to solve this. So in this question you can see a hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. So in the previous question, this hemisphere was mounted. Okay, here we are having a depression. Okay, so first of all, we are going to take the diagram. So let us see the diagram. So this one is again a cube is given to us, right? And here you can see here it is a depression, right, from one face of cubical wooden block such that, and its diameter is given L centimeter. Okay, so it will be same in the previous question like that. The greatest diameter is L, that is taken from one side of cube to the other side. So and here it is taken. Well, how we are going to find it? So the same way, total surface area, or we can say total surface area of this cuboid minus the curved surface area of this hemisphere, and this will be again an extra surface. So we have to subtract because we are taking the total area of this side. We are taking total side, so we are taking 6 faces. So from that sixth face we have to subtract this area. If we are not going to subtract, it means we are having an extra surface area of this particular solid, right? So let us try first what is given to us. So given is diameter of this hemisphere is equals to the diameter of the hemisphere is equals to the edge of the cube, and that is equals to L centimeter. So radius of this hemisphere will be radius of the hemisphere is equals to L by 2 centimeter. Therefore, the total we have to find the remaining, means the solid surface area of the remaining solid. So let us write now surface area of remaining solid, and that is equals to surface area of cube plus curved surface area of hemisphere, or we can say minus base of hemisphere. Base of hemisphere. So surface area of cube is 6a square plus 2 pi r square minus pi r square, or we can write 6a square plus pi r square. So 6 into, so our length is l square plus 22 by 7, radius is l by 2 whole square. So we can write it as, here l square is common, so inside it will be 6, and it can be written as 22 by 7 as it is pi by 4, and it can be written as l square 24 plus pi by 4, or it can be written as l square by 4 24 plus pi centimeter square. So that's it for this question.